Alright, so this video is going to be part 2 of comparison test practice. Okay, so we want to prove whether this series is converges or diverges, and that series is the sum from n equals 1 to infinity of 4 to the n plus 1 over 3 to the n minus 2. So you can obviously see here that this kind of resembles a geometric series. Okay, and what is keeping it from that? Well, this pesky minus 2 right here. So we have to use comparison test. And how we can use that is by just comparing it to the same exact thing but without the 2. Alright, without that minus 2 there. So we have to find the relationship between these two. Okay? And, well, this minus 2, that's going to make the denominator smaller, which makes the whole fraction bigger. So this is going to be greater than 4 to the n plus 1 over 3 to the n. Okay? Now, all that's left to do is figure out if this sum, we'd want this to diverge here because it's smaller than the series that we are trying to find. Okay? And let's see if it does. So we have the sum from n equals 1 to infinity of 4 to the n plus 1 over 3 to the n. Alright, cool. So let's break this apart and try to get some n minus 1's in there. Okay? So to get a 4 to the n minus 1, if we wanted a 4 to the n minus 1, we need a 4 squared out front. Because that 4 squared out front, if you multiply these two together, you would end up with an n plus 1 because you have to add the exponents. Okay? And for this bottom piece here, this is just going to be 3 times 3 to the n minus 1 for the same exact reason. Simplifying this, you get the sum from n equals 1 to infinity of 16 over 3 times 4 over 3 to the n minus 1. Now, since this r is greater than 1, we know that this series diverges, which means that by the comparison test, this series will diverge as well. Okay, so we can write that out in a couple sentences. Alright, and that sentence basically says exactly what I just said. Since r is greater than 1, we know that the geometric series, the sum from n equals 1 to infinity of 4 to the n plus 1 over 3 to the n diverges, which means by the comparison test that the sum from n equals 1 to infinity of 4 to the n plus 1 over 3 to the n minus 2 will also diverge. Alright, we have our next problem up on the board here. Okay, we want to prove that the series, the sum from n equals 1 to infinity of n plus 1 over n cubed plus n plus 2 converges, or that it diverges. Now, for this series here, okay, we can actually get rid of multiple things here. We can get rid of this 1 and the 2, but then we're left with, so if we get rid of that 1 and the 2, okay, in our comparison, then we're left with a n over n cubed plus n. Okay, and that extra plus n here is kind of pesky as well, okay, because this could just become an easy p series otherwise. So what we're going to do is also take out this plus n and just leave the n cubed behind, okay, because we know that that is equal to 1 over n squared. Now 1, okay, we have a plus 1 in the numerator, but we have a plus n plus 2 in the denominator, which is this addition right here is always going to be bigger than this plus 1, meaning that the denominator is going to be bigger than, or actually, I guess this overall fraction will be smaller than this fraction over here. Okay, so we'll get this sign right here. So, since this series is smaller than the series, the sum from n equals 1 to infinity of 1 over n squared, if this converges, then this converges. And this is a p series, okay, is a p series where p is greater than 1, which means that the series converges. Okay, so by comparison test, this series will also converge. and that is your answer. Alright, so yeah, that's about it. That's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the comparison test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.